Example 1.12. An electric field is uniform and in the positive x direction for positive x and uniform with the same magnitude but in the negative x direction for negative x. It is given that electric field equal to 200 I gap for positive value of x equal to minus 200 I cap for negative value of x. A right circular cylinder of length 20 centimeter and radius 5 centimeter has its center at the origin and its axis along the x-axis so that one face is at x equal to plus 10 centimeter and other is at minus 10 centimeter. What is the net outward flux through each flat surface? What is the flux through the side of the cylinder? What is the net outward flux through the cylinder? What is the net charge inside the cylinder? First, we'll draw the diagram. In the cylinder, this is the center. Total length is given as 20 centimeter. And radius of the circular face is given as 5 centimeter. So center to this point, this center, that is 10 centimeter, 0 to point L, that is also 10 centimeter. Step 1, we have to find, first we will find out area of the circular face. Area is equal to pi r square, pi into 5 centimeter divided by 100, that is 0.05 meter whole square. So you got the area 7.85 10 to the power minus 3 meter square. Now, right face, x value equal to, x means this value. This is 0.1 meter. Field is given as 200 I cap. From here to here, field is 200 I cap because x value is greater than 0. Now, what will be the flux? Flux formula E dot area. E dot A. Electric field is along I cap. Area of this portion is also along I cap. Therefore, flux becomes EA. E dot A, EA cos 0. So, flux is equal to E into A. E 200. Area we calculated. So, if you simplify, you are getting 1.57 Newton meter square per coulomb. That is flux to the right. Now, we have to go for what will be the flux to the left circular face. Again, it is not 0 because electric field in this direction is given as minus 200 I cap. Suppose you are telling area of this circular face A, in which direction it will have minus I cap. Therefore, electric field is also along minus I cap and area is also along minus I cap. If you do E dot A, I cap dot I cap is 1, minus into minus plus. So, answer again EA. Flux also becomes EA. Here also flux becomes EA. Here also flux becomes EA. 1.57. Now, what will be the total flux? So, before flux through the curved surface. So, net flux through the curved surface means this one, right? Area vector is upward. Electric field is along x-axis. So, angle theta is 90. Therefore, flux is equal to EA cos 90 equal to 0. So, curved surface not contributing anything for the flux. Okay. Now, we'll go for net flux. This portion, flux due to this portion is 0. Flux due to this portion and flux due to this portion you have to take into consideration. But we calculated both are equal. Therefore, total flux becomes 1.57 plus 1.757, that is 3.14 Newton meter square per coulomb. So, we completed C. What is the net outward flux to the cylinder? Last part. What is the net charge inside the cylinder? When we got the value for flux. Now, charge we want. Gauss theorem. Flux is equal to 1 by epsilon naught times the charge. So, charge is epsilon naught into flux. So, charge is epsilon naught into flux is 3.14. If you simplify, 2.78 into 10 to the power minus 11 coulomb. This is the total charge present inside the cylinder.